there. Thank you for
following this devlog series. I'm recording this devlog from the office as recent incidents made it impossible for me to leave. In my devlogs I'm detailing my progress on porting SystemShock2, a first-person shooter RPG and ancestor of the BioShock series. My goal is to have SystemShock2 be entirely playable in VR by porting it to a modern game engine. Thanks to custom-written importers, I can already import much of the original game levels and assets, but the game logic will have to be written from scratch. Let's get right into this log's progress update. In the last log I said I would focus my efforts on implementing a working pistol. I also mentioned that SystemShock2's modded pistol has a movable slide I would use to implement reloading. Well, as it turns out, there are two versions of the pistol in the game. I didn't know that, but in hindsight it's quite obvious. SystemShock2 has one model for the pistol as an item just lying around in the world, and it has a different one for the player actually holding the pistol. Item models have no movable parts, but the equipped pistol model, which has a movable slide, also comes with an arm and half its triangles missing. This was a common practice in video games, as normally you would never see those triangles during normal gameplay. Half-Life 2, for example, has that exact same optimization. But for VR, this optimization makes the player gun model unusable. So unless I add the missing triangles back in, no moving gun parts in this project for now. Okay. But you know what gun has no moving parts? That's right, the Apollo H4 Argon suspension laser pistol. So I decided to implement it as the first weapon in the game instead and deal with the pistol later. The laser pistol uses energy as its ammunition. Without modification it can store 100 energy units. It has two firing modes, one cheap, fast and weak, and one expensive, slow and powerful. The first problem I had to solve to implement the laser pistol was to find a way to show the player how much energy was left in the pistol. The solution had to be generic enough so that I can reuse it for every other weapon in the game. In most VR shooters, the ammo count is located somewhere on the gun itself, neatly integrated into the model. But because I'm not a modeler and I don't want to modify all the gun models in the game, I came up with a different solution. Introducing the Info Watch. It displays the current weapon's remaining ammunition, but also so much more. It shows player health, psi points and weapon health. Player health and psi points are displayed by these two segmented rings on the watch. Each segment corresponds to exactly one health point or psi point. The rings also show how many of the maximum attainable health and psi points the player has unlocked with the current build. I like this design because it displays vital information in an immersive and quick to access way. A little bit like the health marker in Dead Space, at least I think so. Also, the total segment count of both rings does not change during a playthrough, so the player can visibly see his progress when his available health pool increases. The middle of the watch is reserved to display information about the currently held weapon. It shows the ammo type as a little icon. Ammo count is displayed as two numbers, the remaining ammo in the clip on top, and the remaining total ammo on the bottom. Lastly, there is a small pie chart-like circle that displays the weapon's current health. Because in SystemShock2, weapons degrade with use. Eventually they get jammed and can't be used until they are repaired. Every weapon has 10 health levels, which is represented in this circle as 10 segments. And when a weapon reaches a low health level, it has a chance to get jammed. Now that I had a way to display important information about the player's weapon, I went on to implement importing of weapon attributes. Weapon attributes define most everything about the behavior of a gun. Here is where the difference between Unity's and SystemShock2's architecture became apparent. In SystemShock2 there is a tree-like structure containing every single object in the game world. An object can have multiple properties attached to it and also inherits the properties from its parent. This architecture depends largely on inheritance. Gun objects in a level are actually children of their respective parent gun object. This parent gun object stores the properties that all instances of it share. Properties like maximum ammo count, a weapon chance to jam, and so on. Unity, on the other hand, is all about composition instead of inheritance. Objects also have properties attached to them that determine their behavior, but there is no inheritance tree. Figuring out how to best transform SystemShock2's architecture into Unity architecture is a major engineering challenge. To make a more informed architecture decision, I implemented a prototype safe system next. Yes, it's kinda random, but let me explain. A safe system is like the wiring in a house. You can build the house without wiring and then open up the walls and put the wiring in, but it's way better to put that wiring in before completely building the house. The safe system will touch a huge chunk of the codebase. It has to save the player's inventory, the player's stats, items in the world, item properties, NPC states, gameplay settings, player position, quest states, and so on. It's a good idea to think about how saving and loading will work first when designing a game's architecture. At least that's my opinion. That's why I did it. SystemShock2 takes an interesting approach to saving and loading. To save a level, it basically saves a complete copy of that level with all changed and unchanged values. From then on, when that level needs to be loaded, it ignores the original level file completely and just loads the modified copy. This method can't be replicated in Unity because of the way Unity works. Instead, I chose to implement an entity design. To keep it brief and not bore you with the details, entities are a collection of properties and behaviors. For example, an item with its corresponding data and behavior is now grouped under one item entity. Now, to save a level, I ask every entity to write its data into a container. On load, the entities then are responsible for restoring the previous data by reading from that same container. This is a brief version of how my save system works. This is not a tutorial. I don't know, if you want a tutorial, go somewhere else. So, you may think now that I'll go back to talking about how I implemented a laser pistol, right? Well, you would be wrong. Surprise! Remember when in the last video I said, so no new game geometry for this project, maybe ever? Cool. Well, by completing the save system, I got in contact with the developer of the Dark Engine resource viewer. We compared notes and he told me how to import WREXT chunks, which in the following I'm just gonna pronounce Wrext chunks, because I'm not spelling that again and again. Excited, I got down to implementing Wrext chunks and this was the result. Looks pretty good, huh? But it also has a slight randomized prop placement bug. Quickly I found and fixed a series of bugs, all having to do with modded versions of game files containing unexpected or wrong values. The randomized prop placement is actually caused by a file meant to contain level-independent values, also containing object instances, which were overriding the level-dependent objects. After fixing that, the props went back to normal and I faced a different bug. Some object model files, the files containing object meshes, everything you can see in the game, contained invalid values. My importer relied on these values being correct, but apparently the game doesn't, at all, just runs. I don't know. Luckily, there is a Blender plugin to read those object files, which also doesn't rely on these wrong values, so I just ported that code. Then I fixed a couple of other visual bugs, like some object textures being upside down. That was actually an older bug you might have seen in my previous videos if you were paying attention and not just tapped out. Not just the object textures were upside down, the world textures themselves were upside down too. It's just hard to notice. See here where the watermarks defy gravity and move upwards? That's how I noticed. I also fixed object scaling, which seemed to fail on certain objects. After fixing all those bugs and having a working Wrext importer, I would sum up the progress on mod support by saying we are at a good enough stage now. We got Wrext loading, we got 50% of material loading down. The most important missing thing are animated textures that don't work yet. We don't have any DML loading. but I didn't really notice, so whatever. Okay, enough talking about mods. Let's get back to implementing that laser pistol. In the next devlog. Sorry, all of that did take quite some time to do, and there's even stuff I haven't even talked about in this video. Before I end this video, I'd like to make 2 announcements. I have a Twitter now, actually my first Twitter account ever. Go follow it if you want to see my progress in between my devlogs. The second announcement is, in the future I want to upload videos weekly. Because it's hard to make enough interesting progress on the port in 1 week, I will start making a second series presenting some old game projects and ideas of mine on this channel. Alright, see you in the